finally, today we get to acknowledge one little theorem.
Could I be scared?
That's you can be scared if you want. It is Halloween. We will be discussing the sum of the angles in a triangle. Since you're sitting back there all by yourself, you have to hold up so you don't feel excluded, or you want to stay back. You've established your territory. Your little fight done in the back. I understand. So, you wanted to use this for a long time. I wouldn't let you because you couldn't prove it. So today we're going to prove it. We are going to prove that the sum of the angles in a triangle is equal to 180 degrees. So, there's the theorem. First of all, the sum of the angles in any triangle is 180 degrees, and that's the picture we're going to use to prove it. The question is, how does that picture prove the sum of the angles in any triangle is 180 degrees? You're on your own. What do you got for me? Well, first of all, let's look at the picture. And if you look at the picture, what is it we're trying to prove in the picture?
1, 2, and 3 equals 180.
1 plus 2 plus 3 equals 180. It actually equals 6, but we'll pretend. It's a bad joke. 1 plus 2 plus 3.
I got that one.
Correct. Angle 1 plus angle 2 plus angle 3 equals 180. How are we going to go about doing that? I entered it.
No.
No, go ahead.
Now, angle 3 equals angle 5.
Why would that be true, sir?
Because A, E, I know, some E, I.
A-E-I-O-U. Right, the vowel theorem. Sometimes Y. Well, we're not ready for sometimes Y. Just A-E-I-O-U. You want to try that again?
A-I-A.
A-I-A, correct. So angle 3 is equal to angle 5. So what?
Angle 1, 4, and 5 equal 180.
Why is that?
Because we have form a straight line.
Okay.
I get it. And angle 2 equals angle 4 because of A, E, A.
Nope.
Oh.
You're so close. You're missing one little nugget of information.
Nugget?
It's a word nugget. What do you got? Which two angles? 2 and 4 are congruent by AIA. Okay, that's the basic approach that we're going to take. But before we do that, we got a couple things that we need to address. First of all, I have this green line in there. It's a little hard to see, but there are actually arrowheads on there. They're right there. So I just randomly threw in this parallel line. And Euclid, the guy that did this whole business, he was named after the road, by the way. He only had 4 total postulates. Everything else he proved. But this is one of the things that he couldn't prove. Not the triangle thing, but that line thing. He wanted to be able to draw parallel lines wherever he needed them. And so he couldn't figure out a way to prove that that was true. So he just said, yeah, I'm able to do that. Okay. I can draw parallel lines wherever I want. So I drew in this green parallel line wherever I want. Where did I want it to be? I wanted it to be right through that vertex point there. So I forced that green line to be parallel to the other side of the triangle. By the way, that's called a parallel line postulate. It says, whenever you need a parallel line, go ahead and slap a parallel line in there. Once we've established that, then are you okay?
Yep.
What'd you do? Shark bite?
No.
What happened?
Nothing. I just.
Bear attack?
No. Shark attack.
Shark attack?
Yeah.
Okay. Great white? Mako?
Maybe.
Maybe. Nurse shark?
Tiger.
Okay. Tiger. Good. Good. Hammerhead.
I was thinking that.
Were you?
Yeah.
I must have read your mind. Once we have this established with the parallel line, then we've got everything worked out all nicely. We want to show that angle 1 plus angle 2 plus angle 3 is equal to 180. Whoops, 180. All right, so how did we do that? Well, he also said that angle 1 plus angle 4 plus angle 5 equals 180. Because they're supplementary, right? Oh, I
That's only
tricked
two.
you. Only two angles can be supplementary. They just happen to add up to 180 degrees. Suckers. So then we had angle 3 was congruent to angle 5. Get rid of the angle 5 and stick in an angle 3. We have that angle 2 is congruent to angle 4. Get rid of angle 4 and stick in an angle 2, and lo and behold, angle 1 plus angle 2 equals angle 3. It is not dependent on the shape of the triangle. It's not dependent on the type of triangle. I can take any triangle and do that. And in fact, if I change colors here, I could have done it with a completely different vertex. I could have put a parallel line in here like this and said that that line is parallel to that line. Assign some angle measures here. I already got a 3 there, so we'll make 6 and 7 over here and repeat the whole process again. I can even do it with the other side of the triangle, or other vertex of the triangle. Fairly elegant proof, but it works out really nicely. The other thing you can do is you can cut a triangle out of paper. I'm sure you probably did this in 3rd grade. Cut a triangle out of paper. Did you ever do that? And then cut the corners off and lay them all out, and they form a nice. You put the angles together, and they form a nice little straight line there.
No.
You never did that?
Yeah.
Oh, yeah, I remember.
Well, if you didn't, you were deprived of a major chunk of childhood.
Yeah.
And I would probably consult your teacher about that. Oh, actually, hold on. I got that. Okay, good. Exterior angle theorem. Before we get to the exterior angle theorem, we need to define an exterior angle. Okay. We'll do that up above here. An exterior angle is an angle that forms a linear pair with an angle in a triangle. Why did I write out the word triangle? Especially since I can't spell it. Triangle. So 4 is an exterior angle. Linear pair, adjacent, supplementary. And if I drew in the other exterior angles of this triangle, it would become very confusing. But we'd have a 5 over there. There's 2 over here, so I'd have a 6 and a 7. All these are exterior angles. 8 and 9. But we're just going to focus on number 4. So I'll make all that mess go away. And 9 looked a little wonky. Okay. So, what can you tell me about angle 4? How does it relate to the other 3 angles in the triangle? Other than the fact we already know that angle 4 and angle 3 are supplementary because we established that by saying that they were a linear pair. Have it.
4 of your exterior angles.
No, 4 is an exterior angle, 3 is an interior angle.
Can I use my one time?
Sure. You want to use it now?
Yeah, I'm gonna
You don't know what's coming up later.
I'm good.
You don't want to save it.
I don't want to save it.
Gutsy move.
Drop an email. 1.
What did you just say? No, what did you just say? Sounded like you said dropping an email.
No, I didn't.
What did you say?
I said dropping the turn. How did you hear email?
I did not
Did you
hear
hear
email.
email?
No.
I didn't hear anything.
What did you hear?
Nobody else heard email.
I
said
heard dropping. That's all.
Drop.
He kind
You
of
just
like,
heard dropping, and
Yeah.
then, but he did say
He
something
mumbled.
after. Right?
Yeah, he
okay,
mumbled.
good.
Dropping.
he
So-
needs to enunciate.
To my super sensitive 50-year-old
Yeah.
ears, that mumbling.
Sound like email.
It's like when you play a record back. You don't even know what a record is. Never mind.
Yeah, I do.
All right, go. One time. Here we go.
Angle
Are you gonna
1.
drop the mic after this? Drop the iPad after
Drop
this?
the iPad.
Drop the pencil.
1 plus angle 1 plus angle 2 equals angle
Prove it.
4. So if 3 and 4 equal 180,
Should I write this down?
if you want.
I do.
Okay. So angle 3 and angle 4 equal 180 combined, and angle 1, 2, and 3 equal 180 combined,
How do we know that?
because that's the thing that we just talked about.
And what's that thing called?
The triangle theory.
How about the triangle sum theorem?
Triangle sum theorem, alright.
Notice how theorem is spelled. There's an O in there for some reason.
You're wrong.
Alright.
Theorem.
You're right.
Back to you, sir.
Alright, so then you know that 1 and 2 combined equal 4, because if you Okay. Angle 4 plus if angle 3 and angle 4 equal 180 and angle 2, 1 and 3 equal 180, then angle 4 equals angle 1 and 2.
Why?
I kinda get that.
Oh, yeah, I get it.
I get that.
Don't encourage him, Ben. Why?
Go for it. Maybe
Ah.
the same.
Is there a more elegant way that we can get to
Yeah,
that
I
point?
know. I don't know it though.
Anybody else?
Is that one angle 1 plus angle 2 plus angle 3 equal to angle 3 plus 4? And you cross out the 3's from both sides. So now you know angle 1 plus angle 3 equals angle 4.
Beautiful.
Thanks for this.
Nicely done. It's got your back.
Yeah.
And that's called the exterior angle theorem. The measure of an exterior angle of any triangle is equal to the sum of the other two interior angles. Okay, they're called remote interior angles. The one that's not next to it. Not this guy, these guys. Which I think I have the theorem written on here if I get rid of all this writing. Okay. There it is. Two remote interior angles. The nice thing about the exterior angle theorem is if you completely forget about it, it's okay. You can still work it out. Okay, because you know that these two are supplementary, these three add up to 180, and you can do the same thing that he did for the proof for the particular problem. Shall we look at an example? We shall. After we talk about two corollaries.
Dang.
Actually, I screwed up. I thought there was an example on the next slide. Is this a new word for you? Have we talked about this word? No?
Sir.
Corollaries. You can think of a corollary as like a sub-theorem. It's a theorem, but it's not a theorem that's important enough to get its own theorem. Okay, it's like a, I don't know how you describe it. It's like a theorem within a theorem.
Like a mini theorem?
Mini theorem, I like that. Okay? And they're usually kind of obvious. Is number one obvious? Think about the example that we did at the end of the class yesterday where we had the right triangle. You have a right triangle. One of the angles is 90 degrees. What do you know about all three of the angles? 180. Get rid of the 90. What does it tell you about the other two? They have to be equal to 90, which we also call complementary. Number two, is that also fairly obvious now? What happens if you have two right angles in a triangle?
Then it's already.
Then it's not a
Then it's not a
You ain't got a triangle. That's
You got a
right.
line.
You got two parallel lines.
You gotta lie.
Okay, that ramped up pretty quick, but all right, sure, you have a lie. Thank you.
lie angle.
Right, the evils of geometry. You liar, you. There's an example. I know there was one up there.
Can you go back?
Can you go back?
Yeah, I didn't write any of that down.
You're like, in the PowerPoint.
This slide.
Oh, I misunderstood. Sorry, is that what you wanted?
Yeah.
Oh, my bad. For the next example, I'm actually going to show you two different ways to solve the problem. And you can use whatever method you'd like. Now can I go?
Yeah.
All right, solve that problem. I'll give you a minute to work on it, and then I'll show you two different ways. There you go.
Did you just give us like
Wow. Are the shoulders okay, Mary? Are you stressed a little bit, carrying that attitude around on your shoulders? It's gotta be a little rough, right? It's a heavy burden. Bite my head off. I was just clearing the screen. Jeez.
Are you kidding?
Yeah, we do.
hard. You still think it's not right? Okay. Rebecca got the same answer.
I didn't get an answer.
Oh, there we go. Yeah, I got the same answer. Are you changing your mind now? 83?
Yeah.
Did you all solve it by doing 2x minus 11 equals x plus 72?
Yeah.
Beautiful. So I don't need to go over that approach, right? Let me show you the alternative approach.
I just go over it all.
How's it with? What's the matter? Huh?
I didn't do it.
Sure. The exterior angle is equal to the sum of the two remote interior angles. Subtract x from both sides, I get x equals, add 11 to both sides, 80 tree.
Tree?
Tree, this many.
Okay.
Why is there a tree in the number?
Exactly. Alternative approach. How big, this will be fun, how big is that angle? Forget about this. Megan?
25
Nope, not the degree measure, just based on the picture alone, not on the work we've already solved. How big is that angle? Nicole?
180 minus 2x minus 11.
This angle is 180 minus parentheses 2x minus 11. First of all, those parentheses are extremely important. Okay. Now, what do I know about this angle, and that angle?
They have to equal 180.
They equal 180. So x plus 72 plus 180 minus the quantity, 2x minus 11, has to equal 180. This seems like a little bit of work. Actually, it seems like a lot more work than the theorem. But again, if you forget the theorem, you've always got this to fall back on. X plus 72 plus 180 minus 2x plus 11 equals 180. Subtract 180 from both sides, combine terms, I get negative x plus 82 equals 0. Sorry, that's 83. Trouble with math. Move the 83 to the other side, and sure enough, x equals 83.
Wait, why is the parentheses so important?
Because you have to distribute the minus sign
Okay.
to each of the terms.
So you, why?
I gave up this.
Is that a lot?
So,
Did you hit the wall on that one? Did you hit the wall on that one?
yes.
Okay. You good now? Power through?
Is there another example?
There might be.
Alright.
Let's see what happens when
Let's go.
when we use the magic clicker. There you go.
Oh.
Each number to equal.
Time to come off the porch and run with the big dogs. While you're solving that problem, you might want to ask yourself, just for giggles, I don't know,
Just forget.
just for giggles, how many triangles are in that picture?
1,
lot.
2, 3,
Yeah, good, a lot. I like it. Good. No, solve the problem first. I'm just saying, as you're solving the problem, how many triangles are in that picture?
3, 4, 5, 6, 7. 8. They're 8. 4, 5, 6. Because I'm a genius.
Okay.
You need better one math.
1, 2, 3, 4, 5.
Mary, shoulders.
Great job.
They're 8.
There you go. That's
There
better.
are 8, Dad.
ELE, I got you.
That's
I'm
right.
not seeing this eight.
That's
Yeah.
actually right. It's either 7 or 8. It's not 6.
I know I shouldn't have asked that question.
Can
It's
you
like a
just tell us
shiny
the
bauble.
answer?
There's like.
It's like a cat chasing a laser beam on the wall.
There's a high.
That's actually really fun.
What do I have to do?
I don't know, I'm
They're-
still.
Oh, wait, I get it. So
Oh,
I'm equal
oh.
3.
I made my triangle.
I'm making
Ooh,
it here.
ooh, I got 3.
Are you?
What's his video on? I need to use my calculator. I don't want to do this. All this subtraction.
I got 5.
Wait, what?
So 75 plus
Zoo day. You're welcome.
56. 75 plus 56. That's not 55. That's 126.
Yeah, I got one.
As you're solving this, there's no rule that says you need to solve the numbers or solve the angles in numerical order. There's no reason why you can't say, I don't know, solve for angle 3
Yeah,
first.
5 is really easy.
I like
So is See that piece of paper feels about that. That paper probably doesn't appreciate it when you just
Just not.
No, it's not cool. Okay, if you didn't
Talk less, work more.
I agree.
Yes.
He's a sassy person.
Okay.
Oh, my brain
Whoa.
hurts.
Oh, I know.
I messed up somewhere.
Oh, I know
Of course you did, Paul. Of course you did.
Hey.
Yeah, Alicia.
Yeah.
I know. Okay, so somehow an angle goes on here.
It's good thing you used your one.
Huh?
It's good thing you used your one, didn't
How am I
save it for
supposed to
this.
get that?
One of the angles equals
Oh,
0.
yeah, I know.
Probably not a good
Wait, what are the angles?
scenario.
You gotta-
Equals 0.
I know, that's why I messed up.
All right, all right.
90 minus 40.
Challenge accepted, Ben. Come here.
Hold on.
Dun, dun,
It was about
dun.
to be a major roast session.
I think I got it. I think Ben's a smart kid. I think
And he
he
held
can do it.
aloft the mighty Excalibur, so that Ben shall do the problem.
Alright.
Dude, that was weird.
No.
Show your
Yeah.
Why?
Two of them.
But then.
I got
Hold
that
on, I
too.
might have done the
We got
math
two.
wrong.
No, math is solid.
No, I got that.
But again, why?
Alright, so this equals 90
Here, let me give you a
degrees.
hint on the pen. Turn it that way. There you go.
Gotcha. Alright, I'll just. Alright, this
Just make the
equals
9 bigger.
90.
I like it. Good.
90, because it's right. And then, so and if this equals 90, then these two have to equal 90. And then 90 minus 41 equals 49, pretty sure.
Good start so far. Let's give it up. That way, if he crashes and burns, at least he gets one round.
I got it.
So then this equal here, this angle here equals 90. So then,
No.
No.
yes,
Back
no,
off.
this one here, this
Yeah,
one here.
he's talking
equals
about the
90.
whole one.
Yeah.
Go
not-
ahead.
Not, yeah.
Yeah.
Alright, so then, if this equals 90, and this here, these two have to equal 40.
Oh.
Wait, hold on.
Uh-oh.
Hold on.
Oh,
I might
boy.
have done something wrong here.
Uh-oh.
So I'm predicting
Uh-oh.
that
That's never
these
Play the
equal
lotto a lot?
45. Maybe.
Maybe, right.
They look like it.
I got all of
I didn't get it.
Because we learned that works so well in here.
All of these
I
look
got
equal
60.
after
Alright. So let me go back to my math. And
As opposed to your psychic predictive powers.
yeah.
Okay.
So then this is 90.
Yeah.
So I'm kind of just predicting that
Oh, boy.
this is
Oh, boy.
this cuts it in half too.
Oh, boy.
So then this.
Give me the pen! Give me the pen! Get it! Oh!
Alright, so then this here equals 45.
Sure, why not?
And this one
Yeah.
equals 90.
Uh-huh, why not?
And then
Yeah. Yep.
That's
And one equals 90.
180.
Give me the pen! You go back to your seat. You're banished.
Mr. Reedy.
It's a good thing we gave you the round of applause when we did.
Mr. Reedy, can I try
Trying to
it?
take us all down the dark path. What?
Can I try it?
Are you gonna predict?
No, I'm not.
All right.
I'm gonna.
I wouldn't.
Because I have all of them written down.
At least we got angle 5. Thanks, Ben. Good job.
All right.
I predict Ben did not get the other 4 right.
All right. So angle 3, since that's 90, this has to be 90. So 90 minus 48 is 42. So angle 3 is 42.
I got that. That was really good.
All right, and
Can you move? I can't
Math
see.
and magic.
Is that a 42?
And Mary!
I asked.
Mary!
sorry,
It was your tone.
sorry, I'm bad. All right. So
Excuse me, Michael. Is angle 3 42 degrees? I'm having trouble reading. See the difference, Mary?
Sorry.
42
I like it.
degrees.
Good.
Boom.
That's a big.
Oh my god. You can't do
All of a sudden it became 420.
Oh my god.
We're never getting this done.
All right, so let's see. I'm gonna do angle 2 now. So 49 plus let's see. This has since this is a big triangle. You know,
I didn't even see it.
so 40.
I didn't either.
So 90.
That's
There's
what
7
confused me.
90 plus 41 equals.
Wait,
What did I get for
I
that?
don't think so. I think it would be 49 plus 41 plus 34.
No. It'd be 41 plus 34
Yeah, that's
plus
fine.
49
That's what I
equals
just said.
a big number.
Okay, good.
Molly, I'm gonna punch you.
What did I get? And this ended up being 56.
Oh, that was a big jump. Hold on. Whoa. Where did that come from?
So I added all these
No, it's
together. I got
26.
something, and then I did 180
No.
minus
Yeah, Chef,
something
you got it right.
equals 56.
He's right.
Okay.
He's right.
And then since
No, wait. He's on a roll. I don't want to stop him.
48 plus 56 equals 76, or
Whoa.
equals.
Whoa.
That was wrong.
All right, good.
56.
Equals.
That's 104.
I don't know what, because I didn't.
It's
write-
104.
104, 180 minus 104 is 76,
76. Okay.
Two
Which
equals
means-
76.
which
Nice
means
job.
this has to be 76
Because.
because vertical angle theorem. And then
I got
this,
actually right. 76.
190 minus 34 is 56. And since this is 76 plus 56 is
I'm good at
48. 48.
132, did you say? And then so 180 minus 132 is
48.
48.
Yeah.
Nice shot.
Angle 1 equals
I
104
get it.
because
Boom, math.
You missed angle 104. Angle 1 is 104.
Yeah, oh yeah.
Did I get it?
Because
Why is
because
one
of these triangles and
Yeah,
numbers.
76
Boom,
or
numbers.
180 minus 76.
Yeah, Deb.
I don't get
I
it.
got the same thing.
As he said, boom, numbers.
I know, right?
Okay. So reviewing what he did, he looked at this big triangle and said, well, this angle is part of that big triangle. 41 plus 34 is 75. 75 plus 49 is 124 from 180 gives you that angle measure, which is 56. Okay. Then went on from there. Let me show you another approach. I would have started by saying that this angle is 56. No, it's not. It's 46.
58.
It's 56.
It's 56, right. Just seeing who's paying attention.
It's
Good.
also alternate interior angles with that one.
That's
If you look at it like, oh,
Correct, but we don't know anything
That gets
parallel,
me
do we?
stupid.
Have we established parallels?
all right.
Somebody just got
This is an exterior angle. To which triangle? All of them?
No.
All 7 of them?
40,
No, not the
48,
big
56.
2.
2.
I don't know what triangle number it is. It's like number 6.
There is no 6.
Those triangles don't have numbers.
This angle 1 is an exterior angle to a number of triangles, but in particular I'm looking at that one because I know the 2 remote angles. 48 plus 56 is 104. If that's 104, these 2 angles are supplementary, which makes that 76. 56 plus 76 from 180 will give me angle 4.
Oh.
I got it. No, I don't.
math equals.
Oh, by the way, angle 3 is 42 because that equals 90.
Right.
Now, you don't like that approach? Try a different approach. Look at this triangle. If that's 42 and that's 90, that tells you how big angle 4 is. There's a lot of different things that you can manipulate here. In fact, Shaffis did it without even using exterior angles.
I like how everyone calls him shackles, even the teachers.
I call him whatever.
Call him Joseph.
Michael Joseph Shackles.
Why would I call him Joseph?
Wait, so what is angle 1
Figure
equals?
MJ.
Angle 1 equals.
104.
Call him Joseph.
What is 4 equal?
What did angle 4 equal?
I don't know.
Big number.
48.
48. 48.
48.
Something about it.
That's me right now.
That's really true, actually.
What accent was that?
Purple, because aliens don't wear hats.
Were you going Australian or New Zealand or British?
I don't know. That's what I thought.
So good at accents.